Alright guys, let's go through these together. So if you think about your values for the first one, if I plug in a 0, what do I get? 0. If I plug in a 1, what do I get? If I plug in a 2, what do I get? 4. Okay, and then the negatives, what do you get? What's negative 1 squared? 1. 1. And negative 2 squared? 4. Over 2 on 4. Because 2 squared is 4. Oh, yeah. Alright, how are we with the first one? Walking around, it looked like some of you, that was it. That was the one we got.
I got the second one.
Alright, so the second one, if I plug a 0 in, what is 0 cubed?
0.
Okay. Plug a 1 in, what's 1 cubed?
1.
Plug a 2 in, what's 2 cubed?
8.
So that's kind of off the graph. What about negative 1 cubed?
Negative 1.
Okay, negative 2 cubed.
Negative 8.
So, there's your second graph. Oh. Good. All right, the third one. If I plug a 0 in, what do I get? 0. What about a 1? What's the square root of 1? Okay, do I want to plug a 2 in? No. What should I plug in? 4. And what do I get? 2. Okay, can I plug in negative?
No.
Yeah, what happens if I plug in negative 1? I happens. Yes, you can imagine it.
Oh, I hate those things.
Oh, okay. So there's your third graph. Still a thing, yes. Okay.
What?
The I, yeah.
Really?
If there's like a 4i plus 3 over 7i minus 4, you can
Except you don't get to this year.
But I'm just saying.
Last year did.
It works.
Yeah, your calculator was glued to your hand last year.
It was awesome. Why I aced, I got 110% on the last one.
You don't get to. All right, so let's look at the fourth one. If I put a 0 in, what's the cube root of 0? 0. If I plug a 1 in, what's the cube root of 1? 1. I don't think I want to pick 2. What should I pick? 8. 8. And what's the cube root of 8? So somewhere way out here. Can I do negative? Yes. What is the cube root of negative 1? Negative 4. What's the cube root of negative 8? The cube root graph. Alright, we okay with the first four? Sure. Super confident, sure there, sure. Alright, let's look at the next one.
What the heck?
Okay, so 1 over x. We said if I put 0 in, I'm going to get an asymptote, right? Okay, so I'll draw an asymptote.
Yeah.
An asymptote. And guys, you actually end up with a horizontal one as well.
Like an X. Not an X. It's cross.
Because there's no way to make that equal 0. 1 divided by something will never equal 0, so that's why it doesn't zero. Alright, so points. If I plug a 1 in, what do I get? 1. Okay. What if I plug a 2 in? What do I get? 1/2. Okay, so that's getting kind of small. What if I plug like a 1/2 in? What's 1 over 1/2? 2. Okay. Because I see when I have a fraction like that, that's going to make a bigger number. Because if I keep plugging in 2, 3, 4, it's going to be a 1/2, a 1/3, a 1/4. Like it's getting smaller and smaller. So if you plug a 1/2 in, it actually gets big. Like a 1/3 would give you 3. 1/4 would give you 4. You don't have to plug all of those in. That's enough for that side. And then you just follow your asymptote.
We have a question. So that was a 2, 1.
Here, I'll make you a little chart here. So 1 gave me 1, 2 gave me 1/2, and 1/2 gave me 2. So what's going to happen when I do negatives? Only negatives. So -1 will be -1. -2 will be -1/2, and -1/2 will be -2. Sure.
Yes.
Okay. Give you guys a second on this one. All right, guys, let's look at the next one. This is called the greatest integer function. Or sometimes it's called the step function. All right, this one's just strange looking. It starts at 0, 0, put a dot there. At 1, 0, put an open circle, and then connect them.
What?
Jump up to 1, 1, close circle, to 1, open, and connect. Yeah. Clearly, I've just lost it today, and I'm just drawing your shape. I'm not. They're what? Okay, let me try it. I'll zoom in a little so you can see.
Vertically too? Just the-
No.
Just together, just with the big.
So they connect closed circle to open. Closed to open. Closed to open. Closed to open. Nothing vertically is connected.
We're gonna have to like know these like off the top of our head.
Yeah.
That's bad.
Guys, this is why it's called the greatest integer function, because your y values are only integers. Do you know what integer means?
Not really.
All numbers.
No decimals, no, yeah, so like -2, -1, 0, 1, 2. Okay.
Oh.
Oh, let's go all the way down.
Alright, are we okay with that one? Yeah, do some negatives too. You don't have to like fill the entire graph, but if you like to, if it makes you happy.
So wide.
Always gotta go the extra mile.
It's so, like, it's funny. One of the applications we used to talk about was with cell phones and like rounding up on minutes, but it's things that you can only count in integers. So you're like, yeah, like things where you aren't going to have a partial anything.
So why is it closed?
So that it's still a function. Because if they were both closed, you'd have overlap, and it would be a function. So just remember the parent graph is always closed on the left. All right, guys, the last one there is absolute value. Did you guys know what this one looked like? Yeah. It's a V, so like. All right, 0, 0, 1, 1, 2, 2. Right? You okay with that? Okay. So those are your parent graphs that you have to know. Guys, what I'm going to ask you to do is graph different versions of these parent graphs. Remember when you did your shifting in Algebra 2 last year? So you should know the parent graph and then be able to graph the new one by shifting, stretching, reflecting, all of that good stuff.
Are we gonna like go into that a little bit or no?
That's basically what
I was
today is.
scared.
Yeah, no, I won't just say, okay, good luck. All right, so I know it says with your calculator, but yeah, I don't think you need to use your calculator on this. Do you guys just remember, like, if it's x plus 1, where am I going?
Left.
Left 1.
Don't you go off?
No, if it's outside the absolute value of parentheses. Yes. So guys, number 2, where am I going?
Right to,
Right 2. Number 3, where am I going?
up, oh yeah. It's not the opposite.
No,
No.
outside is exactly.
Okay.
Anybody ever tell you, like, if you're in prison, you didn't do what you should have done, it's the opposite of what you
Oh, never, but I like that. That's
Okay.
cool.
Yes. Oh, have it.
Well, she means
See that?
We
Clearly.
got her board.
All right, guys. What do you think for number 4? Down 1.
Yeah.
Yes. Apparently, we have another number 4. Where are we going?
We're going right, forward, up, to.
Number 5.
Or,
All right. What about 6?
Alright.
Okay, multiply by 3. Yes. That is a vertical stretch. By 3. Stretch, like it gets taller. Guys, you really do just multiply your y values times 3. That's what happens there. What do you think on 7 then? Yeah, so sometimes it's called a vertical compression. You're smushing it. It's getting fatter. But again, like what you would do on a graph is just multiply the y values by 1/5. All right, 8 and 9, we've got our 2 negatives. One of them is flipping over the x-axis, and one is flipping over the y. But which one is which?
The Y.
X.
Just imagine if negative.
That is flip over x-axis. Okay. Number 9, if you look at that, think about it. It's the x that is changing sign. Like x is going from positive to negative. So do you see how that's a reflection across the y-axis? Flip or reflect over y-axis. With absolute value, it won't look any different. But all right, so you guys remember these clearly, right? You remember your shifting rules? This stuff at the top here with the C, that's exactly what we just went over, so we're not going to do it again. So it's a C instead of a number, that's all. So let's try to graph some of these. Hey guys, look at the directions. What else am I asking you to tell me?
Then state the domain. Oh, is this? Oh, I hate this.
It'll be okay.
This
We
is
can
like
do
the
it
all real
together.
numbers or whatever.
Yeah.
Went to the calculator.
All right.
I always guess on this. Yeah, right.
Okay, guys, so number 1, y equals x squared minus 1. So that is the parent graph, y equals x squared, and then down 1, okay? So if you want, you can sketch the parent graph and then draw the new one down 1. I'm going to draw the parent graph in ink that's going to disappear, so...
I'm about to break out the color.
So just so you can see it, then I'll have to shift quickly. So guys, that would be the parent graph, and then where am I going?
To the right, or down.
Down 1. So each point just goes down 1. Okay. No, it's the magic disappearing. right, guys. Are we okay with that graph? Or we need a minute? All right, so we need to state the domain and range. So domain, what do you think? Negative infinity to infinity. Good. Yep, domain is your x's. And then range. Remember with the range, always go from the bottom to the top. So from the smallest to the biggest. So what's the lowest this graph goes? -1. So hard bracket, parenthesis, what am I doing? Close, yep. So -1 to infinity and beyond. Yes, okay. All right, okay with number 1? Yes? Okay. I want you to try 2, 3, and 4.
Whoa. Like maybe 2. I don't know about 3. 4's a no.
Just think about the parent graph and then think about where it's going, okay? So just try those 3. We will go over those 3 together too. I just want to make sure you guys are getting them.
Do what? I love it.
He started it.
No, Sissy.
No, Casey owns
No, it's because at first we would only use it over text, and it's like when someone would hit us with like some horrible news or something, or someone's like completely dead.
Yeah, I knew that always says it. It's such a weird word, I don't like.
I don't know, you know, for me, like,
Is that
What?
no, that's all you hear is the rest of one. At least you hear the rest of the
No, it was
like I don't trust it.
She should have told us.
for this one, race.
Hey guys, don't forget to write the domain and range.
Oh man.
Yes.
Wait, it's still late.
Shark Rapids? Either. Right.
It's too late.
Because it's not in practice. But it's with the act. It's like if it was.
Is it helpful?
Yeah. Because then, like, I don't know if the unit or the.
Yeah, we'll get this
I
thing
have
out.
like 2 minutes later.
But 5 obviously was on this one. Yeah.
I ran into you guys last night.
We planned out the rest of the year, but I just gotta remember.
Alright, who do you play?
Your
Oh,
town.
that's easy.
Don't be saying that, bro. Yeah, there you go.
That's extra.
First one went.
You silly, did you see her dance?
Yes, that's
It's a lot of like really good.
They were so
The first one was hilarious.
You guys actually did a really good job too.
Yeah, by all means.
We only rehearsed for like
Oh,
2 hours.
you guys did a good job. Everyone was listening to
We really messed up on the leg kicks.
Like, in the split spin over. Like, they just didn't plan well. So that meant doing 6 periods in less than an hour.
Did you give them time?
I told him not to. So, like, half the class. So that's why you guys need to.
No, I got the
How we doing, guys?
I got
Guessing on all the
Number 4 is hard. Where is number 4 going?
left.
Left.
Left 4.
Left 4.
That's the whole story.
So that's not going to be right.
Yeah, you don't know. If you really like these stores.
You're only taking 5 steps,
Yes.
but you know,
Sure, I'm gonna get these going.
somehow. And guys, you are going to come up here and graph 2, 3, and 4 for me. So think about which one you would like to volunteer for, or I will be calling on you.
Ben, that's you, bro.
I got it. I'll do this walk away. You'll do 2, okay.
Oh.
You'll do 4. Will you want 3? Okay. Beautiful.
Way to step up for the
Thank you,
squad.
guys.
They want
That means they can
Yeah, that means that you can draw on this thing.
Oh,
And then you'll
dang,
have
I
a
should have
whole
done
new-
number 2, because number 2 is easy.
We'll do 2 more. You'll have another 2. You'll have a whole new appreciation for me drawing.
Yeah, you always do really neat.
And I'm like too tall. I'm like. I know, it's like a little awkward.
a taller.
I know I need a taller. It's something in between these 2 heights.
Doesn't this one get taller?
It doesn't get taller than this one though, because this one's pretty tall. Thomas, you ready to come up and do number 2?
Yeah, I got you.
Okay. And guys, you can pick whatever color you want when you're up there. Oh, no, like. And you can like rest your hand.
Oh, it's not like a smartboard where like you touch it and it messes everything up. Well, you're gonna do a dot right there? Should I show the parent one too or no?
No, I was just doing
This is easy. No, just bang! Close enough.
Megan, right? See, it's not for height, right?
Yeah, it's very honorable. You should get it higher. You're like way taller than me too.
Don't tell you.
Does it ever hurt your hand after the day?
No.
Actually, really? I'll be killing.
Wait, so are you also recording what's happening on here?
Yeah. You're gonna call your speaker and record
What? Let me fix it.
It's not bad. This, like, it should technically be up here. It's a little wider than it should be, but
Still right. I would've got 100 on that.
yeah, you could have shown the one from -8 shifted up. The 8 on top is going to be removed, and it's going to be up to 10. That would be really far. It's okay, yeah. I know. Takes you a while. It's like touch screen, but not. Like it only works with that hand.
So, Miss Lake, for number 4, is the +4? Is that like in parentheses? Okay.
It wasn't that.
So left 4. Do you have to move that? All left over 4.
Alright guys, let's try for number 3. Everything shifted to the right 2. Your domain is now 2 to infinity. Your range is 0 to infinity. And if you want like an IQ of that one, then it just makes because it dashes it for you. It's just drawing. Wow. So it's gonna like it shifts No, anything that's not horizontal, like with the X stuff. If it was going to be a vertical one, it has to be down. Also, anything with horizontal shift is the opposite.
Go all the way. So if you went all the way around,
And if it's not, I can say them out loud. So you have 3 1.
So those are sort of in what the number is. Like if we had had
Well, negative
in front
3,
of
1,
this like a
then
2 outside of it.
-3.5
That'd be a
to
vertical
2,
Could have been another
and 2
with the X
1
positive horizontally, you're not what
But what I'm saying is, like, and then the other one
That's what I'm saying. That's a horizontal string.
is -5, -1, and then -6 to -1/2, and -5.5
Oh, it is negative.
How did you get used to writing on this?
I don't know.
Boom. Number 4 was weird.
Not negative. Yep. Good job, guys. Okay, so when you're graphing these, like on number 3, showing these 3 points, that is definitely enough. Honestly, on number 4, if you show this point right here and this point right here, and then follow your asymptotes, I'm okay with that. Okay? You don't have to find those half ones in between. For the cubed one, these were excellent. I would have liked to have seen one more down here. So 1, 2, 3, 4, 5. Technically, that one should have been there. And then this guy's like way off the charts up here.
That's where I'm headed.
So it's really a little skinnier than that, but
Thomas,
very good
classic.
idea. Okay, guys, so do you understand? I need more than just like one point when you're graphing these. If you're only showing me like one point and then just drawing a shape, that's not going to get you full credit on your class. Okay? Any questions so far?
Does it get harder than this?
We will add like stretches and flicks, but you want to do 5?
Actually, no.
So
6.
So this, like that point is included. So that means the values have to be included in the domain and range. Here we skip over -4. Like that's what the asymptote is, so that's why we have soft breaks. Okay. Okay guys, let me give you a few more minutes. I want you to do a couple more. You'll do 6, okay. Let's look at 6. Let's look at 7. 11? I don't know if and let's do 9 and 10. So 6, 7, 9, and 10. Those are the ones we have left.
6.
And then you guys will get to do these, okay? So decide what you like.
So we got a V going after it.
Which one do you think is
The whole little thing.
so technically the other ones are different?
Yes.
No, it's not.
It'll end up on 3, but it only moves 2.
When you do domain and range,
Yeah, we'll talk about domain and range for 6.
It goes something.
whoa, which one are we on?
Do 6, 7, 9, and 10.
We're just skipping it.
That is changed. The negative is
Oh, I haven't actually. I like these.
I know it's a hard
I
question.
kind of put the chart, but I think I have.
Go down.
get down to.
Those are like the only thing I actually.
Wait, so what's
Oh,
Right, that is.
Yeah, that is that.
So that's fine. Down. This one over.
Yeah. Hopefully.
Yeah, that's it. And then just follow the patterns in there. So that they look scary.
just set that mark over.
Like it comes we have that horizontal line. So Chris, you're gonna do 6 for me, right? No, we can wait a second. Who's gonna do 7 for me? Alright. Who's gonna do 8? Or 9, I mean. Thanks. Who's gonna do 10? Are you guys gonna do 6? So if you think about your clearing function, it was like those were your y values, right? So you could do 2 times those, negative 2 times your y. So 0. So multiply by divide by 5. If I 2, that's 5 will not work. You guys ready or you need a minute?
Man, I messed up on number 6 and like I wrote it 10. I did the absolute value, but it was
So we're not going to do 8. So why don't you always redo it on 8?
okay.
Oh my gosh, smart. Just gonna keep hearing. Okay, come on.
How about I'm supposed to no pressure? It's very simple. This looks so weird.
No.
Now are you doing your work?
Yes. Can I put my hand on it?
You get a 16.
Sit wherever you want. Never let go of something like that.
So I know you can say whatever you want, but I really put sat like somewhere else, so I'm gonna get really mad. Like, if I sat in a rude spot, I would be get mad. Yeah, I throw a fit. For sure.
So, you're going to connect them. Alright guys, that's the graph for 6. It's just shifted to the right too. Domain and range is obviously going to be a little interesting on this one though. Domain, what do you think the domain is?
I don't know.
Yeah, it's everything because none of your x values actually get skipped. If you look at it going all the way across, it covers every x value. So it is negative infinity to infinity. Now your range, this is where it gets weird. What is your range?
Well, there's like
Every other. Every other?
Every integer.
Every integer. So a couple ways I would accept it. You could just tell me all integers. I would take that. It is not all real numbers.
1 plus 1 is a real number.
Yeah, it doesn't cover anything in between 1 and 2 or in between 2 and 3. It's only integers. Integers are different than real numbers. You know how you have the funny little R for real numbers? There's a letter for integers. It's actually a Z. So if you wanted to, you could tell me it's like a double Z like that. Whoa! That stands for integer. And guys, technically the way you should write that, I'm just running out of room here, so do you remember our notation like y such that y is an element of integers?
I'm writing all integers.
Okay. That's technically how you should be writing it. Okay.
Is that how it should
I would like you to do that, or to tell me just all integers, like write it out in words. Okay? And what if multiple choice? What if this is how I write the range choice? You would know. All right, 7. Is that usually what?
Did I shade this and shade that part?
You only shade on inequalities, so we don't have to shade. Thank you. Yes, it's okay. It's not like a smart board.
Okay, cool.
Yeah. No. It's easier to write on.
Because I was like, I don't want to just have a giant like red handprint.
Yeah, it's much easier to graph on than it is to graph up here. So that. You click on that, and then it becomes the range. What? Then this? Well, this supposedly makes this a touch screen, but because this is like, do you see how the board moves? It makes this not work so well. Yeah, that'd be great.
I like the smart board.
I hate it. I like this better than this one. Because I can face you.
Yeah, the smart board glows.
And the smart board would always stop working around the edges. So like I'd go to grab something over here and it would just like swivel. This is better than this one. Okay, you did something good. It's good. I'm glad you did it. So guys, so your graph is good, just your range. Alright guys, so I like what you did with your graph. It's flipped, stretched by 2, domain looks great. What do you see that's wrong with the range? What, do you guys see how 0 is bigger than negative infinity? We always want to go from the bottom up. Okay, you always have to go smallest to biggest, so that should just be negative infinity to 0. Okay. All right, we okay with 6 and 7?
4 by 9.
All right, 9.
Oh my god. I don't know if I like it. Thing. It's just really weird.
You can touch your hand to it.
Oh, okay. Oh wait, that's wrong. Okay. I'm gonna do it again.
Okay.
Oh wait, I did it wrong. I copied this thing. How do you like
So click on that.
Sorry everyone.
And then click on the pen again. Nope. Nope. Yep. Close. Well, Abby, who's in
And the yellow. Pretty little.
Yeah. So guys, I definitely like the domain and range. I'm going to draw the asymptotes in. The only other thing I would change. So did you really plot those 2 points I talked about? Yeah. So I'll put those in there. So I will do the asymptotes first. Okay, so we've got our asymptotes. And then we would be right there and right there, okay? And then that's what you need to follow. Okay, so you have the general idea.
So we would be at 1.
1, -1, and -1, -3. Because normally it's at 1, 1, and -1, -1, and just shift it down. Okay? All right, number 10. Who's doing the things? Okay, I'm like, I forgot or something.
Sorry. I dropped it
Somebody dropped their glass one in here the other day.
That's so awful.
And it was somebody left it off on somebody else's desk. You don't have to show the charts if you just want to show the graph, that'd be great.
Yeah. Oh yeah.
Wow.
No, still fill in the charts. Okay. Just give me Joanne. You get some erase.
Yeah.
All right, guys. This one looks good. That is the square root function, but then there's the 1/2 in front of it. So she just took the y values and multiplied it by 1/2. So 0, 0 is still there. This is now 1, 1/2, and then 4, 1. Okay. Yeah.
For the when there's a 0 and the negative, is there need to be a bracket? Or is it
They should be parentheses. You could put a union in between them if you wanted. But the reason they're parentheses is because it's an asymptote. Like you're skipping over that value. Okay. All right, guys. Questions? Not too bad. Okay.